Okay, so here we have January 2021 Pure 4. So we're going to have a look through this and we're going to do this in walking, talking, mock style, okay? Here we have question number 1. So, find the first 4 terms in ascending powers of x of the binomial expansion of blah, blah, blah. Now, straight away you should be thinking, this is simple. Why is this simple? Because this is in the formula book. Now, when we look at the formula book, okay, we know that in the formula book, the formula starts like this. 1 plus x to the power of n, where, and it says where the modulus of x is less than 1. Okay, so do we have the modulus of x is less than 1? Yes, because it's actually less than 1 over 20. Check. Is it in the form 1 plus? No. This is where we now have to change it, okay? So this is where people go straight away, use the formula, and they don't realise what's going on. We have to make sure, and the formula pretty much is giving you a warning. This is currently 1. What do we have? A quarter. So what do we need to do? We need to factorise out a quarter, right? Okay. So if I factorise out a quarter, I'm going to have a quarter to the power of a half. Okay. Lots of, a quarter times what is a quarter? 1. A quarter times what is -5? -20. There we have it, to the power of a half. Yeah, there's a magical X there. Sorry, I think my pen had a bit of jet lag or something. It's delay. Okay, so now, guys, we're going to have a half. A quarter to the power of a half is a half. And then we're going to have brackets 1 minus 20x to the power of a half. I can now use the formula, and it wants us to find the first 4 terms. So here we go. I'm going to factorise out a half entirely. Okay, now the first term using the formula is 1. So that was easy, wasn't it? What's the second term? Nx. What is my n? A half. What is my x? Minus x. Plus, then we're going to have a half minus 1, lots of minus 20x all squared divided by 1 times 2 plus. Now what's the next one? A half, then what do we have? A half minus 1 and a half minus 2. Then minus 20x all cubed, all divided by 1 times 2 times 3. Okay, so those are the first 4 terms. So let's simplify this now. Now, I'm going to still leave this half out. Okay, so I'm going to have 1 minus 10x. So we're going to have negative 50x squared minus 500x cubed. And then obviously we're going to have plus or minus ... Now we need to multiply this all by a half. So we're going to have half minus 5x minus 25x squared minus 250x cubed plus or minus ... So there we have it, and given each coefficient in its simplest form. So that's 5 marks. And to be honest, it's quite an easy 5 marks. Biggest place we're going to get some mistakes here is not realising that this is a 1, that we have to factor out. Then some of you, I know in this classroom, not mentioning any names, okay, struggle to realise what's a negative and a positive. Think about it this way. You get positive times a negative, this is going to be squared, so this becomes positive. So we know how having a negative. Please watch out for that, all right? Okay, and then we're going to have, by substituting x equals 1 over 100 into the answer for A, find an approximation for root 5. Give your answer in the form A over B, where A plus B are integers to be found. Okay, so step 1, by substituting x equals 1 over 100. So back in pure 2, we'd literally substitute this in and hope for the best, right? Now, we already know that a quarter minus 5x to the power of a half is approximately a half minus 5x minus 25x squared minus 250x cubed. Okay? If I substitute in 1 over 100, this is what's going to happen. Okay? I'm going to have a half minus 5 lots of 1 over 100 minus 25 lots of 1 over 100 all squared minus 250 lots of 1 over 100 all cubed. Okay, what answer is this going to give me? So this is going to give me 1,789 over 4,000. So now what you're thinking, yay, root to the power of 5, because that's what it said in the question, right? Remember, it said an approximate for root 5. Remember, root 5 is 5 to the half. Okay, please don't be caught out by this. Let's substitute it into the left-hand side, 5 lots of 1 over 100 to the power of a half, because we're technically saying inside the bracket should equal 5 to the power of a half, right? What we find, though, is when we substitute this into the bracket, we get 1/5 equals a half. Okay? If I do a quarter minus 5 over 100, I get a fifth. This is root a fifth equals this. However, it asked us to find an approximation for root 5. Okay? So, technically, we have 1 over root 5 equals 1789 over 4,000, right? So what does root 5 equal? Yeah, but 4,000 over 1789. It's really simple. You can just do cross multiplication if you want. If 1 over root 5 equals this, what does root 5 equal? Okay? It's a reciprocal, isn't it? Yeah? So please don't get caught out by that. That was one of the biggest mistakes that people made, was that the most common answer that we had for here was 1,789 over 4,000. But remember, we want the approximation for root 5. If I substitute this into here, I'm not going to get root 5. I'm going to get root a fifth. So then I have to use my brain and then get that answer. If you don't have a brain, you shouldn't be doing A-level maths. Okay, well done, guys. Question 2. I know what you're thinking. It's been a minute, right? When was the last time we saw vectors? Not long. We've got this. Okay? It's a 5-mark question. This is easy. So, figure 1 shows a sketch of a parallelogram. Now, when you say these words, I really want you to think, what does that mean in layman terms? That means that these sides are parallel and equal. That means these sides are equal and parallel. So please make sure they're giving you clues. Okay, it says from A to B. So from A to get to B, we have gone 6 minus 2, 3. So that's for the vector in the direction. How do we know it's a direction vector? Because it tells us on the top there's an arrow. What is an arrow? An arrow is the direction. Literally, it's telling you all the answers. You've just got to read between the lines. Then it says, and BC, so going from B to C, our direction vector, B to C is 2, 5, 8. Perfect. Find the size of the angle A, B, C, giving your answer to 2 decimal places. Now, your formula sheet is not going to help you here. You have to remember the formula. Okay? What is this formula? Who remembers this formula? Cos of the angle equals
D1 times D2 over magnitude of D1 times the magnitude.
okay, the directional vectors multiplied together, multiplied by the magnitude of the vectors. Yeah? So it's really important to note here, and probably the most important thing, because some people make this mistake. Okay? No one knows that this is our tape 2. Our direction vectors, our directions need to be coming out from the angle for this formula to work. Okay? So we're not going to be using the direction vector of AB. We need to have the direction vector of BA, which we know is just -6, +2, and -3. Okay? Because we're going the opposite direction, right? So we just change the sign. So now when we do the dot product, we're going to have -6, 2, and -3 multiplied by 2, 5, and 8. What are we going to get? -12, +10, -24. This is going to give us -23 as our numerator when I add them all up. Okay? Sorry, -26. -26 when I add all these up. Then, what we're going to do is the magnitude. So then we're going to have the square root of 6 squared plus 2 squared plus 3 squared, which is root 49, which is 7, multiplied by the square root of 2 squared plus 5 squared plus 8 squared, which is 93. So now we're going to read the question. Our answer is in degrees. My calculator's in degrees. I'm going to have cos of theta equals -26 over 7 times root 93. And this is going to give us 112.65 degrees. Now I'm going to look at this and realise that this is an obtuse angle. We've done this. Now, if you had positive 26 over 7 root 93, because you did not use the formula correctly, the angle that you technically worked out is this one here. So that means you just need to do 180 minus your 67.35 to get the answer. Okay, now the second part of the question is really simple. How do you find the area of a parallelogram? You can find the area of the triangle and then multiply it by 2. So an area of a triangle is a half AB sine C. Okay, then multiply it by 2. So technically, I'm just going to have AB sine C. Now we know what our A and B are because we know the length of BC is root 93. We know the length of AB is 7, and we know that we have sine of our angle, which is 112.65. And this is going to give me my area, which is 62.3 to 1 decimal place. And remember, we're going to have units squared. Okay, question 3. And I know what you're thinking. Wow, for 2 marks. And you're probably thinking, where on earth do I start? I know we haven't, as a class, done proof yet. However, I'm going to show you how to get 1 mark on this table. Okay, so prove by contradiction. Does anyone know what a contradiction means? Yeah, how we prove by contradiction is easy. If it says prove that there is no greatest odd integer, we are going to prove that there is a greatest odd integer. Okay, so we need to start by, so prove by contradiction that there is no greatest odd integer. So we're going to assume that, so assume that there exists a greatest odd integer, and we could call it whatever we wanted. I'm going to go with n. You get a mark for writing this sentence. Okay?
Wow. Aren't we going to go like even to n, odd to n plus 1?
Yeah, we might have to, but we don't need that for the mark. Right now, we're going to mark for assume that there exists a greatest odd integer n. Okay, so now to get the next part of the proof. What we now need to do is we know, going back to GCSE level, that would we represent an odd number as n? No. What would we represent as odd number as? 2n plus 1, 2n minus 1, 2n plus 3, etc. Okay? So, then we're going to put let n equal 2k plus 1. Okay? Because we're now stipulating that we can't just, when we say let it become n, remember n is not technically an odd number. Or if you don't like this step, you can go straight away to let the odd number equal to k plus 1. Right? Okay. So, then this is literally what we're doing with contradiction is you're talking yourself out of the problem. Imagine it like a sales technique, right? So, for example, if n is odd, yeah, and n squared is greater than n, because that's true, right? We just throw some facts in there. We're just saying if n is odd, which we've said, and we know that n squared is greater than n, right? Is this true for all numbers? No. But we're saying if n is odd and n squared is greater than n, okay? Not or, because remember this wouldn't be true for fractions. So we're now stipulating something. We're like actually putting a fact out there. We're saying for this case right now, if n is odd and n squared is greater than n. Because the n squared would only ever be greater than n if we're dealing with whole numbers. If we start dealing with fractions, obviously they get smaller as we square them, right? So, then, okay, what is our n? Yeah, so then 2k plus 1 squared must be greater than 2k plus 1, right? We'll just state a fact. We've said what our n is, etc. Okay. Then what? We could expand it. So what we're going to get? 4k squared plus 4k plus 1 is greater than 2k plus 1. Not quite. Okay? Now, essentially, what we have to, how do we prove that the left-hand side is greater than the right-hand side right now?
Take 4 common. Oh, never mind.
We can factorize out
2. No.
Yeah, 4 out of the 2k plus 1. 4k.
we could factorize out 4k. So then we're going to get, so you're going to factorize 4k to get k plus k plus 1. It's not technically quite where we are. Okay, we can minus 1 from both sides. So we're going to have 4k squared plus 4k is greater than 2k. Now what? So now we're going to factorize out, so we're going to get 2k lots of what? 2k plus 2. This is greater than 2k. Yeah? This will always be true, right? Now, you literally need to put... Do you remember when we did, what was it? Was it in pure 2? And yeah, we had to show it was greater than. Okay? So we've already said there exists an odd number. We now know that these two multiplied by together is always going to be greater than 2k. Why?
Because k,
Adding two.
because even if k is a negative number, when you multiply k by k, you're going to get a positive value.
Yeah, this is still going to be squared, right? So this is going to be positive. Okay, so we know straight away. So even though we factorized it here, I probably wouldn't go to this step. I'd always go back to the square number. Okay, we know right now if k is negative or odd, it doesn't matter. When we square this, we know that this is greater than or equal to 0. Yeah? So therefore, we know that 4k must be greater than 2k as well. So the whole thing is greater than. Yeah? 4k will always be greater than 2k. Because this is the same as saying that 2k is always greater than k, is it not?
No.
What if it's a negative number?
What if it's a negative? Okay. So if it's a negative, where does this square come in?
Let's assume k is minus 1.
Okay, assume k is minus 1. We're going to have minus 2. Remember that, we're going to add this one on as well.
Yeah.
So we just have to show, right now, we have to assume that this will always be greater than this. How could we do that for this side? Yeah? So when we go down this route here, we're not going to have quite that, but we need to use, this is why we need to use this part here. How can you undoubtedly prove that this is always going to be greater than this?
Something squared plus.
Let's try and get, let's go back to minus 1 here. We're going to have minus 2 here.
The suppose we just move it to the left. Like minus 2k. No, minus 2.
So you're going to have, so you want to show that 4k squared is greater than minus 2k.
No, 4k squared plus 2k is greater than 0.
No, that's actually good.
Why would there be, why would that be plus 2k?
Because you moved it to k.
Like,
Instead of-
Okay, so you don't want to do this way.
That proves that
But
both
this
sides
way
are
you
greater than-
can say something.
would that help? I don't think it would.
No, I think we need to go down this route. So 4k squared is greater than minus 2k.
Yeah.
So k squared is greater than minus a half k.
Yeah.
Okay. K squared is always going to be greater than minus a half k. Is that true or false?
Absolutely.
True.
Absolutely true for every number.
Oh, wait.
Always, sometimes, never.
It could
For
be.
every integer.
For every integer. Okay. So when we're looking at the question, what does it stipulate in the question?
Integer.
Integer. So are we okay then? Yeah? So this is always true for k being an integer.
But what if it's a negative?
Okay, so let's do a negative number. We know if it's negative here, this will be squared. And we know, for example, let's try negative 2. This is going to give me 4. And we know that we're automatically going to half this.
Oh, yeah.
Okay? So we can show a bit of working out. Now this part here is where there's a grey area in the mark scheme, because you can actually do many different ways here. Okay? It just has to be sound, and you just have to really be like, yeah, this makes complete sense. And then the last sentence is you there have to put, therefore, there is no greatest odd number. No greatest odd integer. Therefore, proven. Okay? So, proof by contradiction is very much, you have to start by saying an assumption. You then have to write your facts, write any statements that you're putting in, remember to go back to the question and realise, is this true for integers? Is it true for not? I want you to think to yourself, whenever you do these questions, always, sometimes, never. And then you need to like prove it to yourself. And then you have to write the last statement. We'll do a few more of these, okay? Now, this is quite a lot of work for 2 marks. Yeah. However, you know you're going to get 1 mark for the assumption, okay? As long as you make sure your assumption is done correctly. Maybe write a few statements. Well done. Okay, question 4. So this one should be able to do nice and quick. The curve C is defined by the parametric equations. Show that the equation of C can be written in the form y equals. Okay, so if we want y equals, we need to start. This is literally 5 marks for algebra manipulation right now. So we're going to get x minus 2 equals 1 over t. So what does t equal? 1 over x minus 2. I'm going to substitute that everywhere I see it. So y1 minus 2 lots of 1 over x minus 2 over 3 lots of 1 over x minus 2. It's funny, there was a question like this in a GCSE paper recently, but with A's instead of T's, and it was not worth 5 marks. Right, so, really simple. Let's think about what we're doing. Now, when I have these types of questions, sometimes I find it easier to lay it out like this. 1 minus 2 over x minus 2 divided by 3 plus 1 over x minus 2. Okay? Because that's technically what's happening. And it's nice for us to be able to see this. Now, to add fractions, what do I need to have? Same denominator. So I need to make sure this is the same denominator. So is everyone happy that whole 1 is represented as x minus 2 over x minus 2? Minus 2 over x minus 2. This is now going to give me x minus 4 over x minus 2. So that's the left-hand side done. Remember, this is divided. Now, 3. What is 3 as a denominator of x minus 2? 3x minus 6 plus 1 over x minus 2. So again, we should all be happy with 3x minus 5 over x minus 2. Now, when we divide, what do we technically do? Yeah, we're going to multiply by the reciprocal. So we're going to get x minus 4 over x minus 2 multiplied by x minus 2 over 3x minus 5. Now, I know what you're thinking. We have a common factor of x minus 2. So that means we have x minus 4 over 3x minus 5. There we go. Nice and easy, 5 marks. To be honest, that's not even A level. That's GCSE right there. Okay? Then it says, hence or otherwise state the range of G. What does the range mean?
It's the range of y.
Yeah, and we also didn't finish off A. Right, remember earlier it said T had to be greater than 0, right? So what does X have to be greater than? So that means that X then has to be greater than 2. Okay? Also, we know that X cannot equal 5 over 3.
Why is x greater than 2?
So my range of values for when t is greater than 0, we also know that y, if we go back to the first one, has to be less than a third. Okay? And then if we substitute in x equals 2, we're going to get 2 minus 4 over 6 minus 5, which is 2 over minus 1 equals minus 2. So minus 2 is less than G is less than a third. Okay. So, in this question, you should show all stages of your working. Solutions relying on your calculator technology are not acceptable. However, are we still going to use our calculator to check that we have done this correctly? Yes. So, step 1, let's put it into our calculator. So, Okay, so as you can see, I've put this into my calculator, exactly how it looks. I know at the end, if I get this answer, when I press SD, it might want it wants it obviously in Lund form, in exact form. However, when I put this in my calculator, press SD, if I get this, I know I'm guaranteed 8 marks as long as I've shown all my steps of working. So it's given as a substitution. So first things first, there's 2 things we have to do when we have substitution. We have u equals 3 plus 2x minus 1 to the half. I need to do 2 things. Number 1, I need to rearrange. Number 2, I need to differentiate. Okay? So I'm going to get u minus 3 squared plus 1 divided by 2 equals x. However, I've just realised I've done that, and we don't actually need that at all, do we? Because, can you see the root here?
But there's a free plus.
Oh, so there's a 3 plus. So what do I have to do?
Minus.
I have to minus 3. This is what we need to do. So again, we need to be sensible. So u minus 3 equals root 2x minus 1. So 2x minus 1 is going to go here. Okay? So now we've got this covered. Next one, we're going to have 4. We need to differentiate u with respect to x. Okay, so du by dx. 3 differentiates to 0. Now, remember this is chain rule, so we're going to get a half bracket to the minus a half. What are we going to multiply this by? 2, because that's the differential of the bracket. So this is just going to give me 2x minus 1 to the power of negative a half, which is the same as 1 over root 2x minus 1. So now what I have is this. I'm going to put everything back into its place. So we're going to have 4 over 3 plus. What is the square root of 2 minus 1? U minus 3. So this is going to be 4 plus u minus 3. Dx, and then how do we get rid of the dx? Well, we multiply now by du dx, right? Because, remember, I need to rearrange this. So how do I rearrange this? du root 2x minus 1 equals dx. Okay, so instead of writing dx, we need to write that. So we're going to get root 2x minus 1, which is u minus 3 dx, du. So here we have it. The integral of 13(1). I'm going to have 4u minus 12 over u with respect to u. Now, before all of you start learning this, okay, let's get this fraction completed, simplified. Remember, go back to GCSE. 4u over u is just 4 minus 12 over u with respect to u. Now I can integrate. So now I'm going to have 4u minus 12 ln modulus of u plus c. However, do we worry about the plus c if we're going to start substituting in? No. So I'm going to substitute in between 13 and 1. So we're going to have 4 lots of 13 minus 12 lots of... Okay, what am I now doing wrong? Think about what I've just done wrong. I haven't changed. Remember, these are for x. This is why we did this earlier. So now we need to find u, okay? Sorry, not that one. You know, we can rearrange, etc. So let's go back to this. So instead of 13, what are we going to have? 26, root 25 is 5 plus 3 is 8. and then I get 3 plus root 3. Is that right? Sorry, this one's 4. I miscalculated that. Okay, so now make sure that we're doing this properly. Okay, and make sure you have a checklist of everything that you need to do when substituting. So I'm going to get 4 lots of 8 minus 12 ln 8 minus. Now we're going to substitute 4 in. 4 lots of 4 minus 12 ln of 4. Okay. So 4 times 8. 32. Minus 12 ln 8. Okay. Minus 16 plus 12 ln 4. So 32 minus 16 is 16. Minus 12 ln 8 plus 12 ln 4 is 12 ln. Right there, guys. So I'm going to get 12 ln 4 minus 12 ln 8 is going to give us 12 ln 4 over 8, which is a half, right? So technically now we're going to have plus 12 ln of a half. Right, now, in the question, it wants it in ln 2. What would I have to take out? A power of -1. So this then becomes 16 minus 12 ln of 2. Because if you think, a half to the -1 is going to give me 2. And if I write this as 2 to the power of -1 using log laws, I can bring that down, right? Okay, and now before, I'm not even going to check the mark scheme, I'm going to put this into my calculator. 16 minus 12 ln 2. What do I get? Oh, look at that. You get 7.6822, blah, 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 blah. Okay, now here you can see, this is what's happening. You can see that we get the same thing. So remember, watch out for the mistakes. Okay, remember that you can check this at the end and all of your log laws. Okay, so question 6. Think about this, give it a go. What are we looking for? What is this called? Okay, question 6. So let's differentiate. So 4y squared differentiate becomes 8y dy by dx. Brilliant. 3x differentiates to 3. 6y multiplied by e to the minus 2x. What do we have? Product rule. Do we remember v du plus u dv? Okay, this is pure free. So what is v? 6y multiplied by, what is e to the minus 2x differentiated? Minus 2e to the minus 2x. So it's going to become minus 12y e to the minus 2x plus u, which is e to the minus 2x, multiplied by 6y differentiated, which is 6 dy by dx. Perfect. So we're going to have 6 e to the minus 2x dy by dx. Brilliant. And we have to find dy by dx in terms of x and y. So what do I want? I want dy by dx equals, okay? So I'm going to rearrange this where I'm going to have dy by dx bracket 8y minus 6e to the minus 2x minus 12y to the minus 2x minus 3. So dy by dx equals minus 12y to the minus 2x minus 3 all over 8y minus 6e to the minus 2x. Okay. So we could multiply everything by -1, and you might have 12y to the minus 2x plus 3 all over 6e minus 2x minus 8y. Okay, they're both equivalent, guys. We should be comfortable working with either. If negatives scare you, it's okay. You know, those people who are happy with negatives, confident, either way we do now is easy. Okay then, so the curve crosses the y-axis. If it crosses the y-axis, what does that mean? X equals 0. Okay, and at the point P. So that means we already have, the origin is 0, 0, right? And the point P must be something 0. Okay? These are just facts that we know. They're obvious, but I'm going to write them down anyway because I have no idea what's coming next. Then it says, find the equation of the normal to the curve at the point P. Right. So I need the normal. So I know I need to find the coordinate. I know this is 0. I need to find the gradient of the tangent, and then...
That's the y coordinate. The x is 0.
Sorry, this one's 0, this one's 0, this one's the one we're looking for, yeah? So, then how do we find the gradient of the normal? The negative reciprocal of the tangent, okay? So, first of all, if I know my x coordinate is 0, how can I find y? I can just substitute 0 into here straight away and find y. So let's do that. So, I'm going to have 4y squared plus 0 equals, what's e to the power of minus 2 lots of 0? 1. So then we're going to have 6y. So 4y squared minus 6y equals 0. Okay? So we can take out a factor of 2 and y, bracket, 2y minus 3 equals 0. So we have y equals 0 or y equals 3 over 2. We already know that y is 0 for one of them. So my other point is 3 over 2. Okay, now my gradient. Now that I have my point, how do I find my gradient? I'm going to substitute into what we've just differentiated. So I'm going to have 12 lots of 3 over 2 e to the power of minus 2 lots of 0 plus 3 all over 6e to the minus 2 lots of 0 minus 8 lots of 3 over 2. So remember, this is going to be our gradient of our tangent. So what is this? Which is going to give me minus 7 over 2. So if my gradient of my tangent is minus 7 over 2, what's the gradient of the normal? Positive 2 over 7. Equation of a straight line, y equals mx plus c. 3 over 2 equals my gradient, which is 2 over 7, lots of 0 plus c. Okay, why was this really silly to do? Yeah, because of course it's going to be 3 over 2, the y-intercept. The coordinate's 0, 3 over 2. Everyone's there following me. Remember, guys, you don't have to always follow a procedure, yeah? So we already know the equation is y equals 2 over 7x, and we know our c is 3 over 2. I mean, of course, if you want to double check, that's fine. However, we have now found the equation of the normal. Nice and easy, 9 marks if you ask me. Okay, question 7. Oh, what can you see straight away? Product and an integration, what are we thinking? Parts, magic number 7. Okay? Right, I can't believe it. We're actually going to see this in a real life exam paper. Are we ready to do this? Okay, let's start as we mean to go on. We're going to write the question. Straight away, you should spot that sine, cos, minus sine, minus cos. We know this is a cycle, right? What do we know about e to the x? It's like a loop. If we integrate or differentiate, where do we always go back to? E to the x, right? So, If we have two loops, that means this is going to go on forever. People are going to get caught out by this, but we're not, are we? So now, let's start by making sure whenever we have a loop, we always write the question on the left-hand side. It's going to help us to see what's happening. So here we go. Does it matter which way round we now do this? Now, what are you going to go for? E to the 2x here, and sine to the x here. So if we differentiate e to the 2x, we get 2e to the 2x. Integrate sine of x, we're going to get minus cos of x. So guys, watch what I'm going to do to really help. The integral of e to the 2x sine x with respect to x equals minus e to the 2x cos x minus the integral of minus 2e to the 2x cos x with respect to x.
So why is it minus e to the power 2x cos x?
Because we take away the multiple of this.
Oh, you just
Yeah? Okay, so now I know already on here. Now don't be afraid if you do have a question where you actually have to do this twice. I mean, we know this is going to go on infinite amount of times. However, sometimes we do have to do it twice. So let's start the next thing again. Minus e to the 2x is going to give me minus e to the 2x. Okay? Minus 4, sorry. E to the 2x. Then we're going to have cos of x integrates to sine of x. Okay? So now, we're going to have e to the 2x sine x with respect to x equals minus e to the 2x cos x. Minus, now I'm going to put this all into a nice little square bracket for us, yeah? We're going to have this magic number 7. So what do we get? Minus 2e to the 2x sine x minus the integral of, here we go, minus 4e to the 2x sine x. Okay? With respect to x. So now what happens? Let's just clear this all up a little bit. Minus e to the 2x cos x. This is now going to be a plus, right? So we're going to have plus 2e to the 2x sine x. Now, I'm going to factor out minus 4 from here. So this becomes plus 4. And now it becomes a minus. Are we happy with all of that? Yeah? If I factor out minus 4 here, what happens? This becomes plus 4. And then if I multiply by the minus, so I'm going to get minus 4 lots of the integral of e to the 2x sine x with respect to x. Okay, what we notice is that you should see we've started at the original question. However, if we've got minus 4 lots of this, technically what could we do? Add 4 lots of this integral to both sides. So now I have 5 lots of the integral of e to the 2x sine x with respect to x equals minus e to the 2x cos x plus 2 to the e to the 2x sine x. Okay, how do we get rid of the 5? Divide everything by 5. And are you happy if I just put, I'm just going to change this, guys, to the positive in the front. Minus a fifth e to the 2x cos x. Okay? How do we feel about that now? Plus c. So, I know a few people, this is how best to imagine it. This sentence right here basically says this. Square equals circle plus love heart plus 4 square. Sorry, I mean minus. Minus 4 squares. Because if you think, the square represents e to the 2x sine x. My circle represents minus e to the 2x cos x. My love heart equals this. All I'm saying is, technically, it looks long and big, but we have to go back to shapes. So how would you figure out what one square is? We'd add 4 squares to both sides, right? So 5 squares equals a circle plus a love heart.
So you could use X, Y, and Z.
And now, a square equals this divided by 5 plus this divided by 5, okay? Right then, I hope that's helped some people. I know it's made some breakthroughs in the class. Right, so now, okay, that was 5 marks, brilliant. Now it says, show that the exact area of R is this. Okay, so basically, we want to integrate between something and 0, e to the 2x sine x with respect to x. However, what we do know is along here, what does y equal? 0. Okay? So we know 0 equals e to the 2x sine x. For what values of x is this true?
0.
No, that's a ridiculous statement. Yeah, but I mean, we already know 1 is 0. We already know 1 is 0.
Is it pi?
Is it 2 pi?
Sorry, 180.
Is it pi?
Pi.
180, yeah.
You think it's pi? Should we see? 0 equals e to the 2 pi times sine of pi. Guys, what is sine of pi? 0. Perfect. Basically, we have to make one or the other equal to 0. The easiest way to do this is, without overthinking it, you just say, okay, when does e to the 2x equal 0? When does sine to the x equal 0? Okay? Does anyone know where e to the 2x equals 0? No, because it doesn't, because it's an asymptote.
Oh, yeah.
Okay, so we don't worry about that. We then think, right, we can't do that way. That's okay. When does sine of x equal 0? We know from the sine graph it equals 0 at 0. It equals again at pi. It equals again at 2 pi. Okay, this is where our brains come in. All right? So, now, what is this going to be? Our first solution is pi. Okay, so, did we already integrate it earlier? Yep. So literally all we've got to do is we're now going to do between pi 2/5 e to the 2 pi sine of pi. Guys, what's sine of pi? What's sine of pi? 0. So that's 0. Minus 1/5 lots of e to the 2 pi. What's cos of pi? What's cos of pi?
1.
1. So we know that this is 1, okay? Minus 0. So then we're going to get 2/5 e to the 0. What's sine of 0? Sine of 0 is 0, so that becomes 0. Minus 1/5 e to the 2x cos of 0. What's cos of 0? 1. So I now get minus 1/5 e to the pi plus 1/5 e to the 2 pi. Well, that's definitely gone somewhere wrong, really, haven't we? Sorry guys, this is that's 0. There we go. Now it makes more sense. Minus 1/5 e to the 2 pi plus 1/5. So this becomes 1/5 minus 1/5 e to the 2 pi. Do they have the same denominator? Yes, so we're going to get 1 minus e to the 2 pi over 5. Is that what we were doing? Okay, why do they have e to the 2 pi plus 1/5? Okay, cos of pi is -1, which makes this a plus, which makes this a plus. Okay, which equals this. It's really good that they gave us the answer there. Please do not rely on other people in your exam. Okay, so therefore proved. Okay, and it's easy to spot, like, you know, that's an easy mistake to make, that's -1, negative times a negative. Always go back when you're doing this. The whole point of these walking talking marks is that you're spotting mistakes, you're looking for mistakes, you're figuring out why. So, question A. With a fixed origin O, the lines L1 and L2 are given by these equations, where lambda and mu are scalar parameters and B is a constant. Prove that for all values of B doesn't equal 7, the lines L1 and L2 are skew. Okay, first of all, what does skew mean?
It's neither.
What?
They're not parallel or...
They're not parallel, nor do they intercept. Okay, so that's what skew means. Skew means not parallel, nor do they intersect. Okay, so we've got to do two different things to prove they're skew. One, we've got to prove that they don't intersect. Now, to prove that they don't intersect, we just have to prove that there isn't a value of mu and lambda. Okay, so this one's easy. To prove that L1 and L2 don't intersect, we have to show that -1 plus 2 lambda, 5 minus lambda, 4 plus 5 lambda. We have to show that this does not equal 2 plus 4 mu. Oh, we're back to Pokemon again. -2 minus 3 mu minus B. -5 plus B mu. Okay, so we can do the first two together and they might work simultaneously and we might get some some values. Okay, let's do this then. So I'm going to get 2 lambda equals 3 plus 4 mu. So lambda equals 3 over 2 plus 2 mu. Okay, I'm now going to substitute this into the second equation. 5 minus lambda, which is 3 over 2 plus 2 mu, equals -2 minus 3 mu. So we're going to have, that's 3 over 2 by the way, 5, 10, 7 over 2, quickly. Right, so this -2 mu equals -2 minus 3 mu. So now we're going to get mu equals -11 over 2. Perfect. Now that mu equals that, we can substitute it into lambda. So lambda equals 3 over 2 minus 22 over 2, which equals -19 over 2. So 4 plus 5 lots of our lambda, which is -19 over 2, equals -5 lots of B lots of mu, which is -11 over 2. So I'm going to get 4 minus 95 over 2 equals -5 minus 11b over 2. So this gives me -77 over 2 equals -11b over 2. Multiply both sides by 2, -77 equals -11b. Divide both sides by -11, I'm going to get 7 equals b. However, what did it say in the question? Does not equal 7. So if 7 equals b, this is the only way. Therefore, L1 and L2 do not intersect. Okay, does this mean that they're not skew yet? No, because what do we have to prove? We have to prove that they're also not parallel. Do we remember how to prove that they're also not parallel? We have to do something specifically to show that they're not parallel. Okay, and we also know that they're not parallel because the directional vectors, this does not equal a multiple of 4 minus 3, and then obviously our b, because our b cannot be 7, right? They're not multiples of each other. You have to also write L1 and L2 do not intersect. Therefore, L1 and L2 are not parallel. Therefore, skew. Okay, if you don't write both of those sentences, you're not going to get that final mark. Proving they don't intersect does not prove that they're not parallel. Okay, but we can see that these are not multiples of each other. 2 multiplied by what gives me 4? 2. And minus 1 multiplied by 2, does that give me minus 3? No, so we already know that's not true. Okay? Because we know for them to be parallel. So we just have to make sure to get the full 6 marks. It even says in the mark scheme, we have to specifically state that they don't intersect and they're not parallel, therefore they are skew. Okay, so question number 9, 10-mark question. And figure 3 shows a sketch of part of the curve with parametric equations, tan theta and y equals 2 sine 2 theta. The finite region shown shaded in figure 3 is bounded by the curve the x-axis and the line with the equation x equals root 3. The region is rotated through 2 pi radians to find a solid. Okay, so we know this is volume of revolution. So we know that we're going to integrate between pi. We're going to do y squared with respect to x, aren't we? Okay? We know that. We know this is what it means. And then it says show that the exact volume of the solid is given by this. Now, what we notice though is we notice a few things. First of all, these are parametric equations. So we have it in terms of x. We need to change this now to in terms of theta. Okay? So if we know x equals 0 and x equals root 3, we can already start by changing our limits. Okay, by substituting them into here. So step 1, if x equals tan of theta, we have 0 equals tan theta, and we have root 3 equals tan theta. So in my calculator, I'm going to make sure I'm in radians, and I'm going to find what these are. So we know that inverse tan of 0 is 0. So we know this is going to equal 0, which is good because this is what we have in our question, right? And then shift tan of root 3 is going to give me a third pi. So pi over 3. So that means k is technically pi over 3, okay? So our k equals pi over 3. Brilliant. So now we've changed our limits. So let's actually have a look at what's happening now. So now that we've changed our limits, we have dx, however we want this in terms of d theta, right? So if we know that x equals tan theta, dx d theta equals, and if I differentiate tan, what do I get? Okay, which gives me sec squared theta. So that means that dx equals sec squared theta d theta. Okay? So now we know what dx is. Do we know what y is? Y is in fact 2 sine 2 theta. What can I now do with y? What do I have to do to y? Square it. So if y equals 2 sine 2 theta, y squared equals 2 sine 2 theta squared, which is in fact 4 sine squared of 2 theta. So now I can rewrite this as the integral of 4 sine squared 2 theta multiplied by dx. But what is dx? Sec squared theta d theta. Okay, it wants it in the form p1 minus cos 2 theta. Okay, so let's figure out what's happening here then. I get the integral of, what is sine squared 2 theta? Anyone?
Is it like 2 sine squared?
2 sine theta cos theta. Both squared? Perfect. Then we're going to have the sec squared. What is sec squared?
No, it's just
Pardon?
The bracket squared.
just bracket squared.
Cos theta all squared. Then we have, what's sec squared theta? 1 over cos squared theta d theta. Right, what is 2 sine squared theta cos squared theta? It's another 4 sine squared theta cos squared theta. Multiplied by 1 over cos squared theta with respect to theta. So now we're going to have the integral of 16 sine squared theta. Now, what do we know about cos squared over cos squared? They're going to cancel, so I'm now going to have d theta. It wants it in the form 1 minus cos 2 theta. So what is 16 squared theta? Sine squared theta we know is, what is the cos of 2 theta with the sine squared? Is it 1 minus 2 sine squared? So 1 minus 2 sine squared theta. Okay, so that means cos of 2 theta plus 1, no, sorry, I'm lying, minus 1 equals negative 2 sine squared 2 theta. So positive, so I'm going to have 2 sine squared theta equals 1 minus cos of 2 theta. Right, if I've got 2 sine squared theta equals this, how many have I got? Technically, this becomes 8. 8 lots of 1 minus cos of 2 theta with respect to theta. Now, remember, this is between pi over 3, isn't it? And 0. Is that right? Was it pi over 3? Yeah. Okay, so there we go. Now we've proved it. And that is 7 marks. Now, what you notice about these 7 marks, yes, okay, through pure 4, we had to realise that to find the volumes of revolution, we have to square this and change our limits. However, this is all pure 3 trig that you still need to know. So those of you resitting pure 3, honestly, pure 4 is really going to help, okay, because you need to be revising this anyway. Then, the last 3 marks. It says, hence find by algebra integration the exact volume. Right, so now I need to integrate this 8 lots of 1 minus cos 2 theta. Okay, between pi over 3 and 0, and then multiply over pi. Right, so first of all, so this is the integral of 8 minus 8 cos 2 theta. With respect to theta. Okay, if I integrate 8, what do I get? 8 theta. If I integrate cos of 2 theta, so sine cos minus cos, what am I going to get? Sine. So now I'm going to have sine of 2 theta. I then need to divide by the differential of the bracket. So 8 divided by 2 is 4. So this becomes minus 4. Now I have this between pi over 3 and 0, and then I'm going to multiply everything by 3. So now I'm going to have 8 lots of pi over 3 minus 4 sine 2 lots of pi over 3 minus 8 lots of 0 plus 4 lots of sine lots of 2 lots of 0. Okay? So So now, we know that sine of 0 is 0 anyway. So this is 0, this is 0. However, it's just good to double check. Some people, whenever they assume 0, they think everything's 0. Now remember, why have I done minus plus here? Because it's minus then this whole expression, yeah? So now we have 8 pi over 3. And then what is sine of 2 shift pi over 3? It's root 3 over 2 times 4, so negative 2 root 3. Then we need to multiply that whole thing by pi. So we're going to have 8 pi squared over 3 minus 2 pi root 3. Does it want the exact or does it want significant figures? Exact. And then what we're going to say, units cubed. Okay, so nice. So this is a full 10-mark question. And you can see, like, I know we've done explanations, however, it has taken just under 10 minutes to do. Okay, and I've shown every part of the working. Okay, 14-mark question here. Are you ready? Can we do it in less than 14 minutes? What do we think? Absolutely. Okay, question 10a. It says write 1 over h minus 5h plus 3 in partial fractions. Okay, so that's nice and easy. So we know that 1 over h minus 5, h plus 3 equals a over h minus 5 plus b over h plus 3. So we're going to have 1 equals a lots of h plus 3 plus b lots of h minus 5. In this case, I'd use substitution. So when h equals negative 3, I have 1 equals minus 8b. So b equals negative an eighth. And then when h equals 5, I get 1 equals 8a. So, a equals positive an eighth. So therefore, in partial fractions, this is going to be 1 over 8 lots of h minus 5 plus 1 over 8 lots of h plus 3. Nice and simple. Sorry, this is a minus here. Okay. Then it says the depth in the water of the storage tank is being monitored. The depth of the water in the tank is modeled by the differential equation. Right, guys, when you see the word differential equation, okay, you know you've got to rearrange this somehow and integrate both sides, okay? This is what was happening here. So, it says solve the differential equation. It says given that the initial depth of the water in the tank was 13. So first of all, step 1. We're going to rearrange this to get h's on one side, everything else on the other, okay? So, first of all, if I bring this down, I'm literally going to have 1 over h minus 5, h plus 3 dh equals minus 1 over 40 dt. Okay? Now we're at this stage. We can integrate both sides. So why did we do what we did earlier? We did it so that we could integrate. Yeah? So now, how do we integrate this? Well, we can use our partial fractions. 8h minus 40 minus 1 over 8h plus 24. With respect to h equals the integral of minus 1 over 40 with respect to t. Okay, so let's do this then. What's the integral of 1 over 8h minus 40? Ln of 8h minus 40, and then we need to divide by the differential of the bracket, which is divided over 8. Minus ln 8h plus 24 divided by 8 equals, now remember, we're integrating this with respect to t now, so this is minus 1 over 40t. plus c. Okay, first thing I'm going to do is multiply everything through by 8. So ln of 8h minus 40 minus ln of 8h plus 24 equals, what's 8 over 40? A fifth? Negative a fifth plus c, is that right? T, sorry. Okay, now we know on this side we're going to have ln of 8h minus 40 over 8h plus 24 equals minus a fifth t plus c. Yeah, we're going to have to change the c into ln k. However, can we divide everything through by 8 to make our lives easier? So we're going to have ln of k lots of 8h minus 40 over 8h plus 24 equals minus a fifth t. Actually, before we do any of that, let's actually find c. No, let's keep it like this. Equals minus 5. This is what t equals, yes? So let's substitute in, given that the initial depth of the water was 13 meters. Yeah, t equals 0 and h equals 13. So minus 5 ln of k lots of, what's 8 times 13 minus 40? 64 over 8 times 13 plus 24, 128 equals 0. So are we happy then if we divide both sides by negative 5? Yeah? And then we're going to have ln of 64 divided by, we're going to have ln of k over 2 equals 0. So k over 2 equals e to the power of 0. What's e to the power of 0? So k over 2 equals 1, so k equals 2. Brilliant. So, it says, hence find the time taken for the depth of the water in the tank to fall to 8 meters. We haven't even got what h is yet. So now I need to find what h is. So I can go back to this one, technically. Okay. I know that k equals 2. So I'm going to have minus 5 ln of 2 lots. So I'm going to have 16h minus 80 over 8h plus 24 equals t. Okay, I can divide everything now. I need to just sort this bracket out on the inside. So if I divide everything by 8, I'm going to have 2h minus 10 over h plus 3. And this equals t. So now I need to find what h equals. Right, so now I divide by negative 5 again. So I'm going to get ln of 2h minus 10 over h plus 3 equals negative a fifth of t. So now I can e both sides to get rid of the ln. So 2h minus 10 over h plus 3 equals e to the power of minus a fifth t. Now what I need to do is multiply both sides by e to the minus of 5t lots of h plus 3e to the minus of 5t. I need my h's on one side, everything else on the other. So you get 2h minus he to the minus of 5t equals 3e to the minus of 5t plus 10. Factorise out h. 2 minus e to the minus of 5t equals 3e to the minus of 5t plus 10. Divide both sides. So h equals 3e to the minus of 5t plus 10 all over 2 minus e to the minus of 5t. Okay, there we have it. 7-mark question. Right, so I know some of you had a bit of confusion with this. First of all, I didn't write the step by step, but do you remember the plus c? Because we have some lns, I turned this into plus ln k, right? So this became like c was now ln k. Now, do you remember it doesn't matter if we minus it or add it, etc.? So all I did was to move it to the other side because it's constant. We don't know if it's positive or negative. I just kept it as a positive. So now I said plus c here, but technically I could have put plus c here and not done it on this side. So what I did was I added ln k onto this side, and then obviously that's why k was then multiplied by it here. Yeah, however, it's easier for us to just keep it as a positive constant until we know different. Okay? The main thing here is, as you follow this, you need to make sure that you get to what the question says. Like, this is exactly what it says in the question. It's really simple. It just looks more complicated because of everything we have to do. Okay, so for part C, it says that hence find the time taken for the depth of water in the tank to fall to 8 meters high. So all we have to do, you don't even have to be able to do part A or B for this part. You just have to set 8 equal to 10 plus 3e to the minus 0.2t over 2 minus e to the minus 0.2t. So I'm going to rearrange all of this. Multiply both sides by 2 minus, so we get 16 minus 8 lots of e to the minus 0.2t equals 10 plus 3e to the minus 0.2t. So we get 6 equals 11e to the minus 0.2t. 6 over 11 equals e to the minus 0.2t. So therefore, we're going to have ln both sides. So ln 6 over 11 equals minus 0.2t. So therefore, t equals multiplied by both sides by minus divide. So now we're going to have minus 5 ln 6 over 11, which is approximately, what does it want? Okay, it doesn't say, so just do 3 significant figures. 3.03, and the time taken is the time in days? Yeah, time is in days, which is perfect. Brilliant. And then part D says, according to the model, the depth of the water in the tank will eventually fall to k meters. State the value of the constant k. So it'll eventually go to a certain meters. This is essentially when, sorry, that does not look like a D. This is when 10 plus 3e to the minus 0.2t over 2 minus e to the minus 0.2t. Essentially, this is going to average out at 10, well, not average out, but it's like estimate of 10 over 2, which is going to give me 5. Because if you, another way to think about this as well, if you were to put, for example, like 100, like if you put in a really, really big number, let's just say 1,000, okay, into both, and then we'll see what we get in here. I'll show you y. So like we just think of a really big number, like 1,000 days, for example. So this number is going to get close to 0, and this number is going to get close to 0 as t tends to infinity. And this is what happens here. You put this into your calculator, it's literally on your numerator, it's going to give you 2. And then on your denominator, oh, you can try this into, oh my. Because this number on your calculator, the 3e to the minus 2, minus 0.2 to the 1,000 is going to give you 4.15 times 10 to the minus 87. As you can see, it's a really small number. And you're going to have the same here. This is going to tend to 0. So these two essentially are going to go to 0. And this is how you get your 10 over 2, which equals 5. Okay. So when you think about eventually what happens is when eventually time goes on forever. So you can literally just, as t tends to infinity, this is going to equal 0. Same with this one. So, well done. There we have the full lot of questions done. Thank you for watching. Oh God, there's a lot in that one, wasn't there? And yeah, don't forget to like and subscribe. Have a lovely day.